Hello, everyone. I want to talk about a question that we get a lot at Actionable Agile since really probably the very first day that we published the tool. I'm going to read the exact question off. There's a lot going on here, so I'm only going to answer a part of it. The whole rest of the question I'll answer some other time. But even you'll see that even by answering part of this is going to be quite a long video. So here's the question: if a piece of work is started on a Friday and completed on the following Monday, the cycle time should be 2 days. But because weekends are included, it shows 4 days. Do you have any recommendations about starting work on a Friday if you know you won't finish it on the same day? Including weekends is driving us to delay starting. Does the weekend really inflate numbers? There's about 16 different questions here that need to be answered, but the one that I'm going to focus on is that very, very, very last one. Does the weekend really inflate numbers? So setting aside all of the other arguments for why you might want to include cycle time, why you might want to include weekends in your cycle time calculations. And there are lots of them. There are lots of good arguments, for that. There are other references that you can go check out for that. I want to focus on just, does including weekends really inflate our cycle time numbers? Does that really happen? And in order to do that, we got to go to the data, right? I mean, that's one thing I always say. If you don't know, go grab some data and let's go look at the data. So that's what I want to do. And I've prepared an Excel spreadsheet for this that I want to step everybody through so that you can kind of see what the results are. To set up this simulation, what I did is I went and I grabbed all of the example data out of Actionable Agile. Now, you may or may not know this, but this example data is actually from a real team that I worked with way back when, that we put in Actionable Agile that everybody has access to, when you have a subscription. Just to prove that this is the real data from Actionable Agile, I just kind of created a scatter plot here in Excel. And if you're familiar with the example data scatter plot, you'll see that this scatter plot looks very, very similar to the one in Actionable Agile. So you can see there was no problem with the exporting of the data. There was no problem with putting it into Excel, right? This is the same data that you get in Actionable Agile. And I would encourage you to do this same process with your own data as well. Okay, so now that we have all of this example data, the next thing I want to show you is two calculations. One, for each one of these items, what would our cycle time look like if we excluded weekends in that calculation? So here, we have, for this first item, we have one that started on January 27th, but forgive the American dates, by the way. These are all going to be American dates. We have an item that started on January 27th. It finished on February 8th. If you exclude the weekends in that calculation, then you would get a cycle time of 10 quote unquote working days. We'll talk about why working days is a bit of a misnomer just a little bit later. But you would get 10 working days. The true cycle time, the true elapsed time from start to finish is 13 days. And this seems reasonable. If we subtract out weekends, we would expect, each one of our individual cycle time, excluding weekend times, to be lower. We can go in and we can figure out the 85th percentile for each one of these data sets as well. So the 85th percentile for our cycle time excluding weekends is 13 days, and the 85th percentile for the cycle time including weekends is 16 days. Again, this is what you would expect. Because this cycle time is right around 14 days or 2 weeks, you would expect the cycle time that includes weekends to be somewhere between 2 and 4 days longer than the cycle time that excludes weekends. Okay, so hopefully everybody's following what I'm saying right now, and this all seems reasonable to you. And you might say, right at this moment, you might say, well, obviously, including weekends inflates our cycle time. It's 3 days longer than our excluded weekend cycle time. However, this is not the end of the story. I shouldn't say the only reason, but probably the biggest reason that you're collecting cycle time in this way, and you want to know, is there a difference in numbers, is because what we're actually doing with this cycle time. And what we're actually doing with this cycle time is hopefully creating some type of service level expectation, or in other words, a forecast for how long it will take to get things done. So to see if our cycle time is really inflated or not, what we further need to test is if we use these numbers as forecasts, how does that affect our actual forecasts? And so this is where we go to our next sheet. And what I did is, for every day, I shouldn't say for every day, for most days in January of 2023, and by the way, these are all just, again, quote unquote work days. So there are no weekends here. You can see I start with January 9th, 10th, 11th, 12th, 13th, and then I jump to the 16th, which is a Monday. So I'm assuming no work is starting on the weekends. And I want to say, hey, for an item that started on January 9th, what would our forecast be if we excluded weekends? And what would our forecast be if we included weekends? And right away, you see something that's kind of funny, kind of interesting, I think. If we start something on January 9th, our forecast that excludes weekends is January 26th, and the one that includes weekends is January 25th. Now, oh, and I guess I've got a calendar here so everybody can kind of check. January 26th is a Thursday, and January 25th is a Wednesday. What's going on here is, when you do January 9th plus this 13, remember our SLE excluding weekends is 13 days. When we add this 13 days to January 9th, remember, because we're excluding weekends in the calculation of the cycle time, we also have to exclude weekends in the forecast. And so you'll see what's happening here is, for every single forecast, as you go through this whole list, every single forecast that excludes weekends is longer than every single forecast that includes weekends. You're actually less predictable, if I can say it that way. That's kind of not entirely correct, but you're less accurate with your predictions in this way. You'll see every single one. And it can't be attributed to the fact that, oh, well, some of these are finishing on the weekends, because we saw with this very first one, January 26th is a Thursday, January 25th is a Wednesday. So if we exclude weekends, that's where you're inflating your cycle time, because you're arbitrarily adding 2 days every 5 days to your cycle time forecast. If this isn't enough for you, it's even actually a little bit worse than that, because if we go back to our actuals and we were to say, for every single item that we worked on, what would it have looked like if we would have used that SLE of 13 days to come up with a forecast? How would our actuals actually compare? And when you go through here and you see, how does our forecasted date match up with our actual date? You'll see, remember, again, this 13 days was at the 85th percentile. When you compare all of these numbers in these two columns, what you find out is you're actually forecasting at the 89th percentile, not the 85th, the 89th. Now, this may not seem like that big of a deal to you, but it kind of is, because the whole point of choosing a percentile for a service level expectation is that you have chosen a percentage that represents the amount of risk that you're comfortable with. And by thinking that you're planning to the 85th percentile, when in fact you're planning to the 89th percentile, means that you're being a little bit more conservative than you really intended to be. That could have economic implications down the road. I'm not saying that it will or it won't, but it could. My point here is that we're not being genuine with the forecast that we're calculating. We think we're planning to the 85th. We're actually planning to the 89th percentile, which kind of screws things up. if all of this wasn't enough for you, there's at least one other thing that I want to mention that I came across as I was putting together the simulation in Excel anyway. I didn't try this out with Google Sheets, so I don't know, but there is a problem, a potential problem with Excel, and that is whenever you have a starting date and you try to add a number of working days. And by the way, the function that I was using in Excel it's called the workday function. The function I was using there. When you use that workday function and you add a number of workdays to a date, you'll see here there's no way, at least natively, there's no way to make that calculation inclusive. All of the cycle time calculations, going back to all these sites, they're always inclusive. So if an item starts and finishes on the same day, we don't have a cycle time of 0, we have a cycle time of 1. If an item starts on one day and finishes on the very next day, we count both of those days. It has a cycle time of 2, not a cycle time of 1. In Excel, however, there's no way to make that natively, like I said, to make that workday function inclusive. So if you think you have a cycle time of 5 days and you add it to January 9th, we go over your calendar, January 9th, cycle time of 5 days should be 9th, 10th, 11th, 12th, 13th. It should finish on the 13th, but you'll see here, the answer you actually get in Excel is the 16th. It wraps it around. So there's kind of this funky off by 1 error in Excel. There are a couple ways to fix this. I'm not saying that this is fatal by any means. There are ways to fix it, and I obviously fixed it for my simulation here. I'll leave it as an exercise for a reader to find out for your data what's the best way to fix it. But my point is that the math becomes unnecessarily complex. In terms of doing this calculation, whether we're including weekends or we're excluding weekends. And by the way, we haven't even had the conversation yet about, well, if we're excluding weekends, should we be excluding holidays? And if we're excluding holidays, which holidays? And if we're excluding weekends, which weekends? Because maybe certain teams in different geographic areas have different definitions of what a weekend is. I mean, imagine what the mathematics, how complicated the mathematics gets there. And even if you were to figure all of that out, which I'm sure you could, even if you were able to figure all of that out, you're still getting a worse forecast. So from a data perspective, does including weekends inflate cycle time numbers? The answer, according to this, and like I said, I encourage you to do this with your data, but the answer according to this is actually quite the opposite. By excluding weekends, you're unnecessarily inflating your cycle time. And that by including weekends in your cycle time calculation gives you a much truer, a much clearer, and ultimately a much more predictable way of looking at your process. Hope this helps. We'll answer maybe some of those other questions a little bit later, like, so what do you do? Should you start work on a Friday or not? We've got good answers for that as well. But this video has been way too long as it is, so I'll stop here. And hopefully you enjoyed it, and hopefully this helps. Thanks, everyone.